Let's take on some logarithmic and exponential differentiation problems. How are we going to do logarithmic and exponential differentiation? Let's talk about the derivative. But before to go for the problem solution, let me discuss the proof of logarithmic function. What is the proof of logarithmic function? Suppose if the function is f of x, which equals to the natural log of x, then f prime of x equals to limit of natural log of x plus h minus natural log of x all over h, where h approaches 0. It is according to the definition of the derivative. If you remember, the mathematical definition of the derivative or the differentiation is f prime of x equals to limit of f of x plus h minus f of x all over h, where h approaches 0. If you don't remember, just go back and check the derivative section. The mathematical definition of the derivative or the differentiation is this. Just apply that concept here. Since f of x equals to natural log of x, so for the f, I'm gonna put natural log. Just put natural log here because my f of x equals to natural log. So the function is natural log, therefore I'm gonna put a natural log, but x plus h, not only x. As I have it here, f prime of x is f of x plus h. So natural log of x will be natural log of x plus h minus natural log of x, which is f of x, because f of x equals to natural log of x. Just plug in f of x equals to natural log of x. Here to add h, all over h, where h approaches 0. It is according to the definition of the derivative. Now to take out 1 over h, and apply the logarithmic quotient rule, which equals to f prime of x equals to limit of 1 over h into natural log of x plus h all over x, where h approaches 0. Look what I did. I have h in the denominator, so I'm going to take 1 over h out. So I will left with the natural log of x plus h minus natural log of x. Now there is a rule of the logarithmic quotient rule, which is log of a over b, it equals to log a minus log b. Suppose x plus h is my a and x is my b, it is like log of a minus b, which equals to log of a over b. So I'm gonna put log of a, which is x plus h, over b, which is x. Just apply that simple quotient rule. Now there is another logarithmic rule. Whatever you have in front of the natural log, you can make it the exponent of this section. So can I raise 1 over h here to become the exponent of x plus h all over x? Yes. Don't take this part. Only take 1 over h and make it the exponent of x plus h all over x. Because there is a rule that natural log of a to the b equals to b into natural log a. So I can write that f prime of x equals to limit of natural log of 1 plus h over x to the whole 1 over h, where h approaches 0. Now separate the terms here to have x over x plus h over x. X over x cancels with the x, so I will left only with the 1. I will have 1 plus h over x. When you separate the terms, I applied that simple logarithmic rule, which is natural log of x to the u equals to u times natural log of x. Therefore, I write 1 over h into natural log of x plus h all over h. Therefore, I write 1 over h into natural log of x plus h all over x equals to natural log of 1 plus h over x to the whole 1 over h. I picked 1 over h from here and made it here for the exponent. And then I separated the terms. So when I separate the terms, I will have x over x plus h over x. X cancels with the x, so I will have 1 plus h over x. Now let me do some substitution here to have f prime of x equals to limit of natural log of 1 plus u to the whole 1 over u times x, where u approaches 0. How? I did that substitution in this way. Let h over x equals to u. I just let h over x equals to u here. So h over x becomes u. And similarly, to find the h, what will be the value of h here? Do the cross multiplication here, where h equals to u times x. Remember, u times x. H equals to u times x. So for the h, I plugged u times x. But what about the h here? U approaches 0. Remember, after plugging the value of h, I will have u equals to 0. So u equals to 0 means that u approaches 0. For the h, I'm going to put u here because I did substitution here. For the h over x, I plugged u. For the h, I plugged u times x. H equals to u times x. For the h, I plugged u approaches 0. Because after plugging the value of h, I will have 0 over x. So 0 over x equals to 0. U will be 0, which means that u approaches 0. Since I have 1 over u times x, can I write 1 over u times 1 over x? Yes. Just write 1 over u times 1 over x. Remember, there is a product of u times x in the denominator, so I can write this whole expression equals to 1 over u times 1 over x. Ultimately, when you take the product, you will get the same 1 over u times x. 1 times 1 is 1, and u times x is ux. Now apply the logarithmic rule in the reverse way of this. Like, can I write 1 over x in front of the natural log? It is like b natural log a, which equals to natural log a to the b. Ignore 1 over u. Just pick 1 over x and put it here in front of the natural log, as I did here. Here, I picked 1 over h and make the exponent of this area. But now I do the reverse here. According to the same rule, I'm gonna pick 1 over x and put it here in front of the x. It is the same thing because ultimately this 1 over x becomes the exponent of this whole thing. So whether you put 1 over x here or in front of the natural log, it is exactly one thing. There is a rule, if you remember, natural log of a to the b equals to b into natural log a. Therefore, I can write if prime of x equals to limit of 1 over x into natural log of 1 plus u to the whole 1 over u, where u approaches 0. I ignored 1 over u for a moment. I just picked 1 over x and put it there in front of natural log x. And put it there in front of natural log. Rearrange the expression to have f prime of x equals to 1 over x into natural log into limit of 1 plus u to the whole 1 over u. Just rearrange this expression. Put 1 over x out there and natural log here, and then limit of 1 plus u to the whole 1 over u, where u approaches 0 together, because there is a product among them. So whether you put 1 over x here, or there, it is one thing. Similarly, whether you put natural log here, or there, it is absolutely one thing. I do it for the purpose because look, according to the rule, the value of the mathematical value of the exponent e is limit of 1 plus u to the whole 1 over u, where u approaches 0. This region, this area from here up to there equals to e. E equals to limit of 1 plus h to the whole 1 over h, where h approaches 0. This is the mathematical equality for the constant e. Constant e equals to limit of 1 plus h to the whole 1 over h, where h approaches 0. But for the h, I have u here, and also u here. So this whole thing from here up to there equals to e. Just plug e here. So I can write f prime of x equals to 1 over x into natural log e. Now according to the rule, natural log e equals to 1. So put natural log e equals to 1, I will have f prime of x equals to 1 over x. There I got the derivative of natural log of x. This is the mathematical proof of that simple logarithmic function. I applied the definition of the derivative. My function f of x equals to natural log x. I want to find the derivative, so I applied the mathematical definition for the derivative. I applied some basic logarithmic rules. At the end I got natural log e. So natural log e equals to 1. 1 over x times 1 is 1 over x. There I got f prime of x equals to 1 over x. We know that the derivative of natural log x is 1 over x. But how we can prove it? We didn't know the mathematical proof. We just got the mathematical proof that yes, it is true that f prime of x, the derivative of f of x, which is f prime of x, equals to 1 over x. The derivative of natural log of x equals to 1 over x. This is the mathematical proof of the logarithmic function, natural log of x.